picking up where we left off from section 3.1, we're now going to be graphing linear equations with two variables. So we're going to do this using that same method that we were doing right at the end of 3.1. We were creating a table, and then we were getting an ordered pair, an XY coordinate ordered pair, and now we're going to take that and we're going to plot it on a graph, and it's going to help us graph it. And keep in mind here that right now we're doing linear equations. So linear equations in two variables, what this means is that the x and y variable have an exponent of just 1, which we don't write in there, but that means it's going to be linear. And the graph of a linear equation, just like it suggests, is just going to be a straight line. So it's going to be a line. So technically, when we're graphing a linear equation, you only need 2 points to graph a straight line. You put 2 points and you draw a perfectly straight line through them. That'll give you the graph. We're going to do a little more just for practice, obviously, but technically you only need 2 points for a straight line. So let's start with this example. So let's graph x plus 2y equals 7. And we're going to start by selecting integers of x, -3 to 3. So I'm going to write those down first. So our x values are going to be -3, -2, -1, 0, 1, 2, and 3. And we're going to find all of their corresponding y coordinates by plugging the x coordinates into the equation, and that's going to give us an xy coordinate. So I'm going to go down here a little bit. So let's start with x equals -3. So x equals -3, and we're using x plus 2y equals 7. Okay, so we're going to plug in a -3 into x and solve this for y. So we need to add that -3 to both sides. So we need to add 3 to both sides. We're going to get 2y equals 10. And just for the sake of space, I'm not going to write the intermediate step. We need to divide both sides by 2. 10 divided by 2 is 5. So that's going to give us a y coordinate of 5, which gives us the xy coordinate of -3, 5. Okay, next for -2. I probably won't go through and show all of these. I'll just fill them in. I'll do a couple of them though. So let's doing -2 here, x equals -2. So same thing, we're going to use the equation. We're going to plug in -2 into x. And I'm not going to show up, but we would add 2 to both sides. We would get 2y equals 9. Divide both sides by 2. We get y equals 9/2. So that's the y coordinate. So that's going to give us the xy coordinate of -2, 9/2. And next we'll do it for -1. So we're going to plug in a -1 now. So -1 plus 2y equals 7. So we're going to add 1 to both sides. We get 2y equals 8. Divide both sides by 2. We get y equals 4. So that's a y coordinate of 4. So the coordinate -1, 4 is on there. And I'm going to just fill these out really quickly for the rest of them. You can check on your own if you want to verify that these are correct. And now they're all filled in. So now what we're going to do is we're going to graph it. So we're going to plot each one of those xy coordinates in that third column. And then we're going to connect it with a straight line with arrows on the end. So -3, 5 is going to be right here, left 3, up 5. -2 and 9/2 is going to be to the left, -2. 9/2 is 4.5, so that's going to be right here. Next one, -1, 4, that's going to be right here. Left 1, up 4. Then 0, comma 7 over 2. 7 over 2 is about 3.5. So that's going to be right there. And for next one, 1, comma 3 is here. 2, comma 5 over 2. 5 over 2 is 2.5. And last one, 3, comma 2. So we can verify that we did it correct because they're all in a straight line. None of them are out of that line. So lastly, just connect them and throw arrows on the end, and then we're done. That's the graph of this line. So if we kept on doing other values, we would just get other points directly on this line. Okay, so let's do another one. So let's graph 4x minus 5y equals 20. And this time I'm not giving explicit instructions for what points to put on there for x, so we're going to choose our points. So I'm going to choose the points for x, -2, -1, 0, 1, and 2. The reason I'm choosing these ones is, for one, they're actually on this graph on the right here, and anything close to 0 is usually going to be just easier numbers to work with. Okay, so let's plug in -2. So I'll go down here and plug in. Once again, I'm not going to plug in all of them. I'll leave that to you guys if you want to check. So 4x minus 5y equals 20. So let's find the y coordinate for it. So we plug in a -2 and we solve for y. So 4 times -2 is -8. So solving this for y, we need to add 8 on both sides. We get -5y equals 28. And then we're going to divide both sides by -5, which is going to give us -28 over 5. So that's going to be the y coordinate. Little messy. That's okay. So that gives us an xy coordinate of -2, comma -28 over 5. Next one, let's plug in a -1. So we have 4x minus 5y equals 20. We plug in a -1 into x. And then 4 times -1, -4. Solve this for y. We need to add 4 on both sides. So we get -5y equals 24. Divide both sides by -5. We get -24 over 5. So that's going to be the y coordinate when x is -1. So we get the xy coordinate, -1, comma -24 over 5. So I'll do one more and then I'll fill in the other ones. So we'll do it for x equals 0. So plugging in a 0 into x, we get 4 times 0 minus 5y equals, let's say 20. 4 times 0 is 0, so we get -5y equals 20. Divide both sides by -5. 20 divided by -5 is -4. So that's going to be the y coordinate for 0. Gives us an xy coordinate of 0, comma -4. Okay, so I'm just going to fill in the other ones real quick. And we'll end up with those last two xy coordinates. So let's plot these points. So I'll plot the first one, -2, comma -28 over 5. So -28 over 5 is going to be about -5.6. So I'm going to go to the left 2 and down 1, 2, 3, 4, about 5.6-ish. So this would help if you changed it to a mixed number or you just divided it and got a decimal to realize what value that actually is. Next, for the next coordinate, we're going to have -1, comma -24 over 5. So we go to the left 1, and -24 over 5 is about 4.8. That would put us about right here. Next, we have 0, -4, which is going to be right there. Then we have 1, comma -16 over 5. 16 over 5 is going to be -3.2. So about right here. And lastly, 2 comma negative 12 over 5. Negative 12 over 5 should give us negative 2.4. Right there. Okay, so it looks like it's decently accurate. Not perfect, but probably didn't mess anything up. So connect them, and it looks something like that. So we should be labeling these. Go back and maybe label the other one. This is the graph of 4x minus 5y equals 20. Okay, so it's another straight line, arrows on the end. Okay, so this brings us to an x-intercept. So the x-intercept of a graph is going to be the x-coordinate of a point where the graph intersects the y-axis. So the x-intercept is where it's intercepting the x-axis. This means that the y-coordinate is 0. So whenever we have an x-intercept, the y-coordinate is 0. So that means our x-intercept as a coordinate will look like x, comma 0. So it'll be whatever the x-intercept is, comma 0. For the y-intercept is going to be the y-coordinate where the graph intersects the y-axis. So this means the x-coordinate is 0. And that means it would look something like 0, comma, whatever the y-intercept is. Okay, so for example, let's use this graph. So let's say we already graphed it using the same method we just did. Use the graph of y equals x plus 3 to find the x-intercept and the y-intercept. So let's do the x-intercept. Take a look at that. So the x-intercept is going to be right here, where it's crossing the x-axis. So this is going to be, it's crossing at negative 3. So that means we can either write x equals negative 3, or we can write it as a coordinate negative 3 comma 0. So either way would work, as long as it's labeled x-intercept. For the y-intercept, that's going to be where it's crossing the y-axis. It's crossing the y-axis right there. That's going to be at the point y equals 3, or written as a coordinate, it could be 0, it would be 0, comma 3. Okay, so those are the x and y intercepts of that graph. And for the next thing, we can use intercepts to help us graph linear equations. And it's nice using the x and y intercepts because we're going to be plugging in zeros. We're going to get 2 points, and then we can just plot those 2 points and connect them with a straight line, and we'll be done. So the way that we can do this is find the x-intercept by setting y equal to 0 and solving for x. And then finding the y-intercept by setting x equal to 0 and solving for y. Then draw a straight line through the 2 points and arrows on the ends, and then we're done. Okay, so let's do this example. Let's graph 2x plus y equals 4 using the intercept method. So let's find the x-intercept. So the x-intercept means y equals 0. So we're going to have 2x plus y equals 4. We're going to plug in a 0 into y. So it's 2x plus 0 equals 4, which is 2x equals 4. Divide both sides by 2, we get x equals 2. So easy enough, that's our x-intercept. For the y-intercept, now what we're going to do is we are going to set x equal to 0. So plugging in a 0, we get into x, we get 2 times 0 plus y equals 4. 2 times 0 is just 0, so we're left with just y equals 4, which is our y-intercept. So for our x-intercept is 2, that's going to be right here. Our y-intercept was 4, that's going to be right up here. All we have to do is connect it with a straight line. So it would look something like that, and that would be the graph of 2x plus y equals 4. Okay, so that's pretty easy because we're plugging in zeros and all we need is 2 points. Plugging in zeros, things are always going to cancel and be a lot nicer. So that was pretty easy. So let's do another one. So let's graph y equals negative 3 over 2x plus 3. So let's find the x-intercept. So x-intercept means that the y is 0. So plug a 0 into y. And solving this for x, we need to subtract 3 on both sides. So we're going to get negative 3 equals negative 3 halves x. So next, what we're going to want to do here, a little bit trickier with these ones, we're going to want to, you could think of it as dividing both sides by negative 3 over 2 to solve for x. I'm going to write this one out. I'm going to multiply. The better way is to multiply by the reciprocal. It's the same exact thing, but it looks a lot cleaner. Because dividing is the same as multiplying by the reciprocal. So I'm going to multiply both sides by negative 2 over 3. That's going to completely cancel those. We're going to be left with x equals negative 2 over 3 times negative 3. The negatives are going to cancel. The 3's are going to cancel. We get x equals 2. So it was a lot cleaner doing it this way. And for the y-intercept is going to end up being pretty simple. Y-intercept means x is 0, so we're going to plug a 0 into x. So negative 3 halves times 0 plus 3. That first term cancels, we get y equals 3. So x equals 2. Oops. X equals 2. Y equals 3. Connect them, and we get our graph that looks something like that. So this is y equals negative 3 over 2x plus 3. Okay, so for the next thing now, it's going to be the graph of horizontal lines. So far, the graphs that we've done weren't vertical and they were not horizontal. So let's do horizontal lines. So horizontal lines are always going to be in the form y equals b, where b is the y-intercept of the line. So it's just a number. So it's going to be y equals a number. These are called constant functions. So you can see here in this little graph right below it, it's a horizontal line crossing at the y-intercept of b. And it's as simple as that. They're pretty easy. So let's do this graph right here, y equals 3. All we have to do is go recognize that it's y equals a number, meaning it's going to be a horizontal line. So we go up to y equals 3, and we just draw a horizontal line, and that is it. So this means that this is independent of what x is. Y is always going to equal 3 no matter what value x is. So next, for vertical lines, you can probably guess what it'll be for vertical lines. Vertical lines are going to be in the form x equals a, where a is just a number, and a is the x-intercept of the line. And as you can see here, we have this vertical line, x equals a, crossing at the x-intercept of a. So y equals a number, it's horizontal. X equals a number, it's vertical. So let's graph x equals negative 2. So x equals negative 2, we recognize it's x equals a number. So that's going to be our x-intercept. So here's negative 2 right here. And we just draw a vertical line, arrows on the end, label, and we're done. So these ones are the easiest kinds of lines to draw. A couple more. So let's see y equals 0. So y equals 0, the reason I put this one on here, it's a pretty common mistake. So y equals 0, we go to 0, so it's right here, it's actually at the origin. It is a horizontal line. So this is y equals 0 is actually the x-axis. The reason I mentioned that it's a common mistake, people see y equals 0 and they think it's the y-axis, but y equals 0 is actually the x-axis. So it has no height. It's just at 0, y equals 0 the whole time. And for the next one, we have x equals 0. It's the last one here. X equals 0, so we go to 0 for x. Once again, it's at the origin. It's x equals a number, so it is a vertical line. So it's going to be a vertical line, which is the y-axis. So y equals 0, horizontal line meaning the x-axis, x equals 0, vertical line meaning the y-axis. So just be a little bit careful with those ones. Okay, so that's it for section 3.2.